Hey folks, okay, well I wanted to run through a kind of quick intro to lab exercise 2. So in this one you're going to be developing a program composed of 4 different functions where I give you pretty specific details on what I want the functions to look like in terms of parameter lists and return types and that sort of thing, and to get your program working appropriately to call all of those and perform the desired computation. So I'm going to start off by going through kind of a quick recap of some of the details on getting the lab exercise. Maybe we'll sidetrack just for a moment and look at how to get your feedback for lab exercise 1, just as a quick recap on that. And then we'll get into talking about the lab itself. So again, if you previously went through and did if you remember in part 2, well, here, let's show that. In lab exercise 1, we had a useful tools and tips section, and in there we had a little blurb on how to clone the feedback repository. So these are the commands that you're going to be going in and typing in, if you haven't done that previously, right, to get the feedback repository that'll have your feedback for lab 0, lab 1, that kind of thing in it. So at the moment I'm going to assume you've done that. And let us pop back to lab 2. But again, if you've done that, then if you go into your CSCI 160 directory and into your feedback directory, then you do a git pull. It should go off. Oh, in this case, I've already pulled the updates. But this will have, again, if you have a read through there should now be a labx1 in your folder as well that will have the feedback that I've given you for the marks and my comments on your labx1.cpp. So you can kind of do that if you haven't had a look at it already. All right, what else did I want to take a look at? So in terms of getting labx2, remember that's the same kind of idea as we've done for the previous lab. So from our home directory, so right, do a cd to make sure you're in your home directory, and do your make-f, make 160. And for this one, we want to create CSCI 160 labx2. And this should go off and do this fork and clone and a whole bunch of other bits and pieces. And eventually it finishes up, and we can go into our 160 and into our labx2. And there's the usual makefile and labx2.cpp. And as usual, our labx2.cpp is pretty much just an empty comment for now, and we're going to trash that and rewrite it. So maybe I start off right away and throw in my name and proceed from there. So as far as the lab exercise goes, again, what you're going to be doing is going through and writing a program that consists of 4 functions, and I give you the names for each function and what it expects in terms of the parameter list and what it expects in terms of actual behavior. So you're going to create one function called welcome user, and pretty much this is just going to be a bunch of output describing what the program does from a user perspective. Welcome to lab 2. In this program we'll get a value from you and do whatever it's going to do to it. So again, just a couple of short printfs or a couple of short couts telling the user what the program does for them. And purely from a user perspective, don't tell them about all the gory code details. You're just telling them that this function gets a value from you and prints out whatever the computation result is. I think in this case we're computing twice the square root of a value or something like that. So our getUserData function will be the next one. So this is going to take a single parameter. So again, you're going to have your getUserData, and then in your parameter list it's going to be a long and whatever we want to name your parameter. And it's going to return a long. Right? So you want to get your profile right for this. It's going to return a long, getUserData, a long as a parameter. And what it's going to do is prompt the user to enter a value, an integer less than or equal to, and whatever that number was, right? Whatever got passed as a parameter. So I can call the function once with a maximum value of 10, call it again with a maximum value of 100, that kind of an idea. It's going to read in whatever they respond with, store it in a variable. No error checking yet. We haven't got that capability just yet. Oh, actually, no. Pardon me. We are going to check that. Your first draft, I probably wouldn't throw in the error checking because we'll be covering that in Friday's lecture. Sorry. So ultimately, we're going to check and see if that read actually worked and if the value was valid. And if not, then we're going to return a value of 0. So basically, if they enter garbage or they enter an incorrect value, then ultimately we're going to say, oh, that was an invalid value, that wasn't an integer, or that was too big an integer, and we'll just have the function return 0. And if the value was okay, then we'll return the value that they entered. Again, just yet, we don't have the tools necessary to do the error checking. So your first draft, just get it to read it in, trust it, and return it. All right, and again, if the read was not successful, if it failed because the user entered garbage, then we're going to clear the garbage out and print an appropriate error message. If the read succeeded, so they actually did give you an integer, but it was too big, then we'll give a different error message and return a 0. And if it worked, we'll return whatever they entered. All right, so essentially our main routine is going to be going off and calling the welcome user, then calling the get user data and storing it in a variable. Then it's going to go off and call a function to compute the results, which is going to take the value that we just got as a parameter, do some computation, and return a long. So in this case, the function's going to use the square root routine from CMath to compute the square root of whatever the value is, and then return twice that. So return 2 times the square root of whatever the value is. And again, this is all going to be, you can use the square root routine. Again, it expects doubles, it'll work on a long, and we'll store the result as a long. And then ultimately we'll have a function called display result, where we pass it the original value and we pass it the result, and it says, I processed value whatever, and the result was whatever. So this is pretty much the idea for our 4 functions. None of them are terribly complex, but it gives us an opportunity to play with creating functions, calling them from our main routine, and getting some good practice with this. So in the main routine itself, what I want done is to have a constant for the maximum permitted user value, which is going to be 2047, call the welcome function, call the get user data function, passing it that constant. And again, this is the structure I want you to create. Don't go off and stick the constant in the get data routine. I want the main routine to have the constant and pass it as a parameter to get user data, so the get user data is actually usable with calls with different values, and store the value it comes back with. Pass that value to compute results and store whatever it comes back with, and then eventually call the display result, passing it both values. I don't mind which I/O format you use, CNC out or scanf, printf, but again, as we were discussing in the lectures, pick one approach or the other. I either use the I/O stream approach or use the CSTD I/O approach. Don't try and mix and match the two of them. I believe you got 2 weeks for this one, so it's due just after Thanksgiving. Details on the labs page. And again, we'll have the lab sessions next week to go through, and I can help you with debugging and any issues that you've run across, particularly since by then we will have seen how we can do error checking on the cin and on the scanf. And then again, once you're finished, don't forget to do your make submit. So, I've gone through and created my brilliant program, and I can do a make submit, and that will send it back for marking. All right, that is pretty much the idea I wanted to go through. I wanted to spend just a moment to talk about the iterative development idea again. This notion that we want to implement one small piece of the program at a time and get that working, and then move on to our next step. So I did stick an example in there to kind of walk you through the beginning. And the idea was, typically if I'm going to do something like this, as a first draft, I'm just going to stick my design in pretty much as comments and just a skeleton for my program. And then piece by piece, I'll go through and expand on it. So in the beginning, I'll have my hash includes and my using namespace, right? I'm going to need my CMath for that square root routine. And I'm going to say, okay, well, what am I going to do? I'm going to have my prototypes for the 4 functions will come up first. So I'm just sticking in a comment to remind me, okay, here I'm going to put the prototype for the welcome, the get user, the calculation, the final display. My main routine is going to need the constant that it has to declare, the variables for the original data value and the computed result. It's going to need to call the welcome function. It's going to need to call the one to get the user data and store the result. Well, pass the constant and store the result. It's going to need to call the function to do the calculation, right? Pass the value and store the result. And it's going to need to call that final display function where we pass both of the variables. Right, so again, I'm just thinking about the layout and just kind of documenting that. And as I'm writing my program, I'm just going to kind of fill in 1 or 2 pieces at a time and compile it and see if it works so far. Right, so then below the main routine, I would have the 4 full versions of the functions. So I've just stuck in comments for that, right? My welcome one's going to go here, my get user data is going to go here, my calculation, my final display. So I'm going to compile that and make sure that it compiles okay, just to make sure that I've got my libraries right and I've got my syntax for the main routine generally right. It doesn't do anything yet, but just to make sure that I haven't introduced syntax errors yet. Now, at that point, I'll pick what I'm going to do next. What am I going to implement next? What's going to be my first chunk, if you like, of development? And so maybe the first thing I'm going to do is that welcome user function. Right? It was supposed to be a welcome user function. It doesn't return any values. It just does a bunch of printing information out from the user. So I go through and say, okay, well, it's going to have void for a return type since it doesn't return anything. The function name, the parameter list is pretty much empty since we're not, there's no data that we need to display, just the instructions itself. So I'll have my prototype for it. And in my main routine, maybe I'll declare my constant and those couple of variables that I need, right, since that's nice and straightforward so far. So I'm going to need the constant with the 2047, my value that I'm going to process, a variable for the value I'll process, and a variable for the result that I calculate. And I'm going to introduce the call to my welcome user. Again, no parameters to pass, no return value to worry about. I just put in the call to the function. And then in terms of the implementation, I'll put in the implementation for the function. So again, my welcome user is just going to be, again, pretty much the same as the profile up above, void welcome user, no parameters. And then in the body, I'll just have a couple of couts, welcome to lab exercise 2, and then a description of whatever it is this program actually does, right? Computing twice the square root of the value that you give me as an integer. So you'd have a short description in there. Don't give me the blah, blah, blah. Again, this is a first pass. I can go through and compile it and see if it works. And, right, I can run it, and all it should do at this point is print out that little welcome message. But I can see if I've got my prototype right, and my variable declarations right, and my call to the function right, and my implementation of the function right. And if that all works, then I can say, okay, that part's good. Tick off one box. And on my next pass, I can go through and maybe do something similar with the get user data function. Right? And for the get user data, then I might say, well, I know that the get user data says there's supposed to be a whole bunch of error checking and things in it. But maybe for a first pass, all I'll have it do is the cout and the cin and the return pretty much. And if that works, then at some point in the future, I'll add the error checking. Right? So we just add one chunk at a time, compile it, test it, see if that part works, and move on to the rest. That way you've always got something working. You're always making progress. And if you run into syntax errors or behavioral issues, then you can be reasonably sure that they stem from the chunk of code that you just added. And it simplifies your debugging process. All right, I think that was everything I wanted to introduce for Lab 2 for the moment. We will see how things go.